From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Don Felker.
And I'm Kaushik Gopal.
Welcome to the show.
Before we begin today's show, I want to take a quick moment and thank our sponsor, BuddyBuild. Now, I'm going to stray a little away from our talking points again because I want to tell you how much I love BuddyBuild. I use BuddyBuild on a daily basis and Instacart, and I'm not even saying this because they're just a sponsor. We previously had this convoluted setup with our tests running on an iMac in our IT department, which had Jenkins set up. We had a test Android device connected to it. The device sometimes would go down, then our tests would fail. The iMac would go through a macOS update, and then we'll have that security credentials dialog pop up. So we'll have to go to that floor and again get it set up. It was just too much. Because I'd heard of BuddyBuild before, I thought, hey, you know what? This is so painful. I'm just going to give it a shot. And oh my God, my life changed. Trust me, I'm saying this with all the joy in my heart. It is by far the best mobile CI system I've ever come across, hands down. It's super configurable too. So if you want to run UI tests directly on a real device, you can just go onto their interface, flip a couple of switches, and boom, you have direct Google Firebase Test Lab integration. They even post that little video of your tests running on the actual device. And that's not the only thing. They have GitHub, Slack, Bitbucket, Jira, Pivotal Tracker, HipChat, all the integrations that you probably are using at work. BuddyBuild's whole objective is to help developers engage with their end users in a quick way. It's the fastest way to build your app, run your tests, run all those lint checks, and then distribute it to the end users. Seriously, I highly recommend them, and I'm so glad that we have them as a sponsor for our show. Head on to the link fragmentedpodcast.com/BuddyBuild, and you can try it out. Thanks again for sponsoring today's show, BuddyBuild. Another day, another opportunity to learn more Kotlin. In today's episode, I want to touch on the topic of visibility modifiers in Kotlin. Specifically, the one that got me a little confused and a little interested was the internal modifier. What is the internal modifier? What are modules? In this episode, we'll talk about the differences between visibility modifiers in both Java and Kotlin, making our way to this new modifier that's introduced in Kotlin. We'll also talk about the defaults. What are the default modifiers? What are the default behaviors? When should I use what? All of it in this episode. Listen on to find out more. On to the show. Before we start, a super quick primer. What are visibility modifiers? Well, it's a fantastic name because that's exactly what they do. Modify the visibility of your member or your class fields. If you've ever studied CS in school and Java was your first language, the term encapsulation might ring a bell or come to mind. It's just a fancy word to describe the process where you bundle or wrap your data so it's ready to be consumed by the outside world. Now, what does that mean? Well, you only expose the APIs and methods that you truly want from your class, and you want to hide everything else. How do you hide everything else? Using visibility modifiers. So whenever you hear the term visibility modifiers, you should basically automatically think of public, private, protected, and the keywords that we know of. Now, I'm going to presume you folks already are aware of how these modifiers work in Java. We have public, which is expose everything. We have private, which is the polar opposite, namely hide everything. We have protected, which in Java is basically expose only to this class and the subclasses. And very importantly, also other members in the same package. You should remember this because it's actually a little different with Kotlin. I'll say this again. Protected is essentially expose whatever field or member I've marked as protected only to this class and subclasses, and also anyone who happens to be in the same package as me. So that's protected in Java. And the last one is the default, which is package private. If there's one Java modifier that you probably are not aware of, it's maybe this one. This is actually the default in Java. So if you don't provide a modifier, the compiler automatically assumes you mean package private. Package private is basically the same as protected, but it's a little more tighter in its restrictions. So if you recall what I said with protected, it's subclasses and anyone in the same package, right? Package private restricts protected just a little more and says that no, it's only the same people in this package. So I don't care if you're a subclass and you happen to be a different package, that's a no-go, right? So package private is truly only the package. Now, Java is really big with the whole package thing, and you'll find this as a mildly differentiating theme with Kotlin. Kotlin doesn't really care that much about packages. Actually, I should rephrase that. Kotlin is a little loose with its packages. You can take a file, put anything in that file, put it in any directory structure, and just slap on the package name on top. And Kotlin understands that that's what you mean. But Java is a little more uptight about its packages. It actually values the directory structure. You can't just willy-nilly throw it in any directory that you want. And as we've just seen, Java has an operator exclusively just for the package level, right? Which is package private. Now, with all that in mind, this is a Learning Kotlin episode. So let's look at how Kotlin deals with visibility modifiers. Let's knock off the easy ones. The public modifier is pretty much the same as in Java, basically expose everything. However, there are some notes that I want to call out in the way Kotlin does its public modifier. Now, there is no package private in Kotlin, right? So package private does not exist in Kotlin. So what is the default? Well, unfortunately, or fortunately, as depending on who you ask, the default visibility in Kotlin is public. Yep, that's right. In Kotlin, they chose public as the default. Now, this is kind of unfortunate for a couple of reasons, at least in my opinion. Because the first reason is almost 95% of the time, you actually never need to use the public modifier in Kotlin. So if you are actually typing in the public modifier, you probably are not thinking about your visibility modifiers, right? Because Kotlin has this other operator that we'll get to called internal, which almost always does the job better. So when you're writing your Kotlin code, keep that in mind. Almost always, you never need to mark something public. There are a few cases, and I'll try to touch those a little later. Now, you may ask, okay, what's all the fuss about? Why do we care that much, right? Well, we care because you want to minimize accessibility of all your classes and members as much as possible. Now, this should sound familiar if you're a regular listener, because that's actually effective Java item number 13 by Joshua Block. We covered this in episode number 63, and I'll make sure to drop that in the show notes as well. Essentially, you want to minimize accessibility as much as you can. Now, JetBrains is super open, and they usually welcome feedback from the community. So Logan from Square actually brought this up in a very well-articulated discussion. So what I'll actually do is I'll drop a link to that Kotlin discussion forum thread, and you should go through the whole thing. Logan has done a fantastic job of summarizing it and explaining very clearly why public as a default may not necessarily be the best decision. It's a fascinating discussion where some of the names you probably recognize have added with some very nuanced arguments. If you're looking for the TLDR as to why JetBrains essentially chose public as the default, Kotlin's development lead, Andrei Breslov, rounds it up with this. He says, we believe that the benefits of having public by default outweigh its drawbacks. And he actually mentions this in that forum thread that I talk about, including those that you have pointed out. So that discussion has pretty much been put to rest. So the story behind the public modifier in Kotlin is that it's the default. So you do well to remember that. Okay, let's proceed with the next obvious modifier, which is private. Similar to Java, it's the polar opposite to public, and it's the most restrictive modifier. So essentially, members, fields, anything that you mark as private is only visible in the same scope. On a small side note, this word scope is a very important term for programmers, and you should be intimately familiar with it. As I was learning JavaScript back in the day, it became extremely important to understand the meaning of scope, the word scope. So if you understand scope, when I say that the private modifier is visible to only other members in the same scope, it should make sense to you immediately. I'll drop some links in the show notes that I use as a reference whenever I want to point folks to this topic of scope. It's actually a technical paper, but it's well worth the read. I have this stored away in my Evernote notes, so I thought it'll be beneficial to listeners to have a look. So take a look at the show notes. I'll make sure I'll drop those links there. All right, so we have public, we have private out of the way. Now let's look at the third operator, which Kotlin also has, called protected. this is where things start to get a little juicy in terms of like the differences. So in Kotlin, when you mark anything as protected, it's strictly accessible only by the declaring class and the subclasses. This, I think, is actually a great decision by Kotlin because intuitively it makes more sense, right? If I say something's protected, then you would think that it's only available to like that class and anyone who like derives from that class, right? So I think this was a good decision. But you should remember that this is very different from Java. Well, not very different, but pretty different. Java protected also exposes it to anyone in the same package, right? This is not true for Kotlin. I like to think of protection in Kotlin as sort of the anti package private for Java, right? So what I'll do is I'll drop in the show notes this very rudimentary diagram that I came up with. And this is how I visualize it in my head. And it makes it very easy to understand this protected scope. So if you think about it, protected Java has classes and subclasses, and it has anyone in the package scope, right? Anyone in the package scope alone is package private in Java, right? So that's one arm. And the other arm is very similar to what Kotlin thinks of as protected, which is make it visible only to this class and anyone who derives from this class, right? So if you look at the show notes and have a look at that diagram, like immediately, I think it should make sense. I think this was a good decision in Kotlin for protected, but do remember, if you're very familiar with Java, then this is an unexpected behavior. Okay, so now we come to the very last operator, which is actually the one that prompted me to come up with this episode in the first place, and that's the internal modifier. So just how package private essentially applies to anyone in the same package level, right? That's what package private is. It's a broader scope. It says if you're in this package, package private is for you. You can see this, right? Kotlin uses the internal modifier in a similar fashion in that it says anyone who's in the same module. Now, module, I'm saying this with like, inverted quotes. Anyone who's within the same module gets to see stuff that's in the internal modifier. Now, the problem is, what is this module? This module is a new concept, but the problem is it's slightly more exposed in scope than package private. So if you think about it in terms of the repercussions, it's actually very different from package private. So when you translate package private to internal, it's maybe the best approximation, but it's very different in terms of repercussions. You should not equate the two in your head as you convert your Java code to Kotlin code. Now let's look at what the official docs first say about internal and module, because these are new concepts to us that exist only in Kotlin, right? The internal visibility modifier means that the member is visible within the same module. We covered that, right? Now you may ask, WTF is a module? To which JetBrains has an answer. A module is a set of Kotlin files compiled together. This can be an IntelliJ IDEA module, a Maven project, a Gradle source set, or finally a set of files compiled with one invocation of the ant task. I'll be honest with you, unless you're a library developer or you're writing APIs, this whole internal modifier is kind of bullshit. As an Android developer, you probably won't benefit as much from the internal modifier, but you have to remember Kotlin is not just for Android developers, it's for a larger scope. Obviously, I'm being a little facetious here with my description of what a module and the internal modifier is. There is actually a huge benefit if you're writing APIs and implementations, right? So let's think about this. You could write your API interfaces as public, which means I'm building this library, I'm writing my API interfaces, and I'm marking those as public, which means anyone can see them, right? So anyone who's outside of the package, outside of the module, if you import this library, you can see this because that's what public is. Now, what you could do is inside that library or inside this module, as I'm going to call it, you can make all the supporting code that your implementation depends on as internal. Now, what's the benefit of this? The beauty of doing this is that it's almost public in the scope of your library or module, so you can access it pretty freely in your own siloed world of this module. So if you're writing an API or a library and you're marking something as internal, it's as good as being public, so you can freely access this inside this library or module. Now, once you package this and make it as a third-party library, and then you make it ready for the world to consume, what happens is all of that internal scope, because now you have transcended the boundary of a module, you're no longer in this thing that we call a module. All of those members are now no longer accessible, which means effectively, when you hop between modules, they're private. So this makes it really convenient if you're an API or library developer. You can mark internal, you can, from all over the place, you can do what you do inside your library, access this thing because it's internal, it's freely accessible inside your module. And then all you have to do is publish a library, and nobody gets access to all those internal gory details, right? They only see the publicly accessible classes. So if you're a library developer, you're writing APIs, the internal modifier is actually a boon. This is really smart, and I think a smart move on Kotlin. But as an Android developer, let's be honest, we mostly just have one main app module, right? Now with instant apps and the push towards Gradle being more optimized when you have multiple submodules, this might change and we might start to see the benefits of the internal modifier in Kotlin. But as it stands now, almost most of the Android projects that I've seen at least typically have just one main app module, right? So if you mark something as internal inside that one single monolithic app module, that's essentially making it public to everyone inside your app. So if you always thought of public being very open and it mattered to you that something was public or protected or packaged private in the Java land, internal basically is public. So you have to be very careful about just willy-nilly using internal, right? Because inside your world of the app module, internal is, for all practical purposes, public. All right, one last point. Remember how I told you right at the start that there's really no reason to use public, the public modifier in Kotlin? You should always almost never need to use public. Well, now that we understand what the internal operator is, this should start to make sense. If you're in your little app world, internal is pretty much the same as public. If you have that single one's main app module, you never need public. You can just mark it as internal, right? And in the spirit of minimizing accessibility, internal is one level lower than public. So there's really no reason for you to use public. Unfortunately, as you remember, the default in Kotlin is public. So that discussion that I pointed you to where Logan articulated everything, that's the case that they're trying to make is well, you might as well make it internal. Wouldn't making the default internal be better? So now that you understand what internal is and what public is, you can sort of understand why this is a contentious argument. I want to close out with a couple of more thoughts and pointers. Java has package private, and that's the default. You have to remember that. Kotlin does not have a concept of package private. It has a new modifier called internal. And the default is not this internal. The default is public. Protected in Java is a little wider in its range. It's a little more encompassing. It takes care of both classes, subclasses, and everyone in the same package. Kotlin's protected, however, does not actually bother about the concept of packages as much. Kotlin's protected essentially says, nope, it's only these classes and the subclasses. You should think about this a little more in your actual coding and daily practices. I think protected now has become way more intuitive, and you should start using protected more if you didn't already. Another very big difference that I didn't point out earlier is with the way protected works in Kotlin. It's a little bit kooky, but I think it actually makes a lot of sense and was the right choice. So let me explain what happens. If you override a protected member in Kotlin, and you don't explicitly specify the visibility, what happens is it actually maintains the protected visibility. This makes sense intuitively, right? But let's walk through why this is a little kooky. So I have a parent abstract class that I'm marking a function or a method as protected. Now I'm overriding this protected method in my subclass, right? And I'm not explicitly saying protected again. I'm just sort of letting the default modifier do its thing. What is the default modifier in Kotlin? The default modifier in Kotlin is actually public. So if you override a method in your superclass and you don't specify a visibility, you would think it's public because that's the default. I've not explicitly pointed out a modifier. But actually, what really happens in Kotlin is it maintains the protected visibility. So if you don't explicitly specify something, it actually just keeps it as protected. I think this makes sense. I think this is the right decision in the spirit of always trying to minimize accessibility, right? But it shouldn't throw you off guard, because if you took the example and applied the same in Java, it would not be the case, right? So just keep that in mind. This might seem a little confusing at first, but if you take a moment to really think about it, all of this actually makes a lot of sense. By the way, if you actually wanted the overridden method in Kotlin to really be public, right? This is potentially, you remember how previously I said 95% of the time you never need to use the public modifier? This is that 5% of the time, right? Because you're overriding something. If you don't specify a modifier by default, it's going to be protected in Kotlin. But if you want to expose that, if you want to make that public, then you have to explicitly provide the public modifier here. So this is like that 5% of the time where it actually becomes really beneficial to be able to use the public modifier. All right, folks. I hope you found all of that information useful. Definitely have a look at the show notes. I'll try to add more snippets and resource links that I used in coming up with this episode. I think it's truly important, even though the visibility modifiers might seem like a very basic or fundamental concept, and it may not be as enticing. Personally, I felt that whenever I learn a language, having a very firm grasp of the fundamentals helps you. And hey, if you're actually interviewing and they ask you about Kotlin, you can actually point out some of these nuances, because not too many people spend the time to actually understand these. So brownie points there. Anyways, thank you all so much for listening, and I will catch you in the next episode. Before we finish today's show, I want to take a quick moment and thank our sponsor again, BuddyBuild. BuddyBuild is a mobile-optimized, continuous integration and delivery platform. Their CI service was built specifically to help us mobile developers. Their platform also helps you engage with your end users in a super easy way. Check them out at fragmentedpodcast.com/BuddyBuild. Once again, that's fragmentedpodcast.com/BuddyBuild. Thanks again. That's it for the show, folks. Fragmented is hosted by Don Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.